Great, so let's try the next problem, which is number 10. So suppose that we flip a fair coin until either it comes up tails twice or we have flipped it 6 times. What is the expected number of times we flip the coin? Okay. Alright, so maybe we can start keeping in mind what if the case of this. This would mean that n minus 1 over 2 to the power of n would be the probability, because we're saving the last flip to be the tail. Okay, so we're flipping it 2, 3, 4, 5, 6 times, and we're saving the last case be the tail, and probably there will be for the remaining 5 spots, we will have 5 heads and 1 tail somewhere distributed within these 5 spots. Okay, so n of heads would be 1, 2, 3, 4, and number of tail would be 1. Sorry, it should be like this. Okay, so in that case, we can start to count in the form of this. So let's just count the number of tails. What if the tail just comes up twice in a row? So n is 2. This would just be the case of tail and tail consecutively. So the probability of that would be 1 over 4. What if n is 3? So we're thinking about the cases where tail comes up twice. So that would be head, tail, or tail, head, tail. So we only have 2 cases, and the total number is 2 to the power of 3, because we're flipping it 3 times. Let's count the cases where n is 4. So the probability of having head, tail, head, tail, and also tail, head, tail. So this would be 1, 2, 3 cases out of 2 to the power of 4. So you'll see why this is the case. If our n is 4, then it would be 2 to the power of 4, and the numerator would be 4 minus 1, which is 3. So in that case, we don't really need to count the rest of the cases. I mean, feel free to do that just for your homework as an exercise, but we would know that this would be using this formula. This would be 5 minus 1 over 2 to the power of 5. So 5 minus 1 over 2 to the power of 5. We have the last case of n equals to 6. So this, I think it would be easier. P of having the tail number of 6, this would be the case where actually it's 1 minus all of these 4 previous cases that we have calculated. So it would be 1 minus 4, 1 over 4 minus 2 to the power of 2 cubed minus 3 over 2 to the power of 4 minus 4 over 2 to the power of 5. Okay, and then we'll just call it x for now. You guys should be calculating this for your homework. All right, so your final answer, since it's asking for the expected number of times, so that would be we multiply this n times the probability. So how to get to the final answer would be 2 times 1 over 4 plus 3 times that probability. So it's going to be 3 times 2 over 2 to the power of 3. And you keep doing this. Now we multiply 4 times this, add with 5 times this, and add that to 6 times the x. So I'll let you guys finish that to your homework, and I'll tell you guys the answer. Your answer should be 3.75. That's what I got after doing some calculations. So make sure you guys have the same answer after showing all of these calculations on your homework. All right, so let's go on to the next problem, which is 12. Suppose that we roll a fair die until its 6 comes up. The first problem is, what is the probability that we roll the die n times? So let's think about that case first. Okay. Let's try to find a pattern. So what this is we're trying to get something like this in the previous problem, where we got to this was a general form that we were actually able to derive before going through all of these steps, but now we're going to do the opposite. So actually, let's count when probability of n equals to 1. So n again stands for the number of times. So what's probability of having, when you first roll a die, a fair die, and 6 comes up? That would be 1 over 6, because a die has 6 faces. Okay, now let's move on. What's the probability of n equals to 2? So 6 comes up on your second try. So first try, you should have 5, the probability of not having a 6, so you have 5 options, numbers 1 through 5 out of 6, times your second attempt should be 1 over 6. So you know this is 5 over 6 to the power of 2. Let's think about the case where n is 3 now. So 6 comes up on your third try after you roll the die 3 times. Okay, so this, we have 5 over 6. We have 5 options. Any numbers other than 6 should be rolled. Same thing here. Any numbers except 6 should be rolled. And for the last case, it should be only 6 that's rolled. And these are independent events because none of these, the die doesn't really depend on the previous roll. So this would be 25 over 6 to the power of 3. Okay, so you can keep this going, but I think you get a chance. Probably the next one is the 4th times, and you'll see just 5 or 6 repeated once more. So this would be 5 to the power of 3 over 6 to the power of 4. So from these cases, we can derive our equation, or generalized equation of P, where n is x, the number of times is x. This would be 5 to the power of x minus 1 over 6 to the power of x. So from here, we can know that this is a geometric distribution with the parameter of p equals to 1 over 6. So there are some of the concepts that should have been covered in Calculus 2, your previous classes. So therefore, we can go now on to the b. What is the expected number of times we roll a die? The expected number of times this is going to be 1 over 1 minus p. Again, this is a geometric distribution, which would be 1 over 1 minus 1 over 6. So that's going to give us the value of 6 as the answer.